Hello, everyone. This is Ernest and James. We are your hosts for the Modern Infrastructure track of All Day DevOps. This will be the last presentation in this sub-part of the track, and then at 3 Eastern, 2 Central will be the keynote for the West Coast set, and there will be a keynote and yet another set of talks. There will be a separate streaming URL for that that'll be on alldaydevops.com/tracks.
Yeah, and just as always, we've been talking about this all day, but you can get hooked into the community as we're having conversations with the speakers afterwards at alldaydevops.herokuapp.com.
Great. Next up we have Lee Calcote, another Austinite. For as we know, Austin is the center of all things DevOps. Shots fired. But he is Senior Director of Technology at SolarWinds. He runs the microservices and containers meetup here in town, and I hear in late breaking news that Karthik has gotten him to take over the Docker meetup as well. So, he has a presentation for us on characterizing and containing container orchestrators. Once you move to containers, those wily little critters are creeping all over the place, and you need a framework to wrangle them and get them in order. It is much like wrestling cats. So with that introduction, over to you, Lee.
Oh, fantastic. Thank you, Ernest. Thank you, James. Good to see you guys again. I am dialing in from, apparently the center of the DevOps universe here in Austin. So good to see you guys online for once, I guess, instead of in person. That's right. I am going to talk to folks today about one of my favorite topics, container orchestrators. And I'm going to apologize up front to the extent that we've got a potato, tomato thing happening with container orchestrators and cluster managers. If cluster managers is your term, I'm sorry. It's going to be container orchestrators for the next 30 minutes. Speaking of which, we're going to try to cram in 4 of these bad boys into the next 30 minutes. So we may move at a brisk pace. To the extent that we do, take note of the URL down below. You can get access to the slides there, as well as I'm sure James and Ernest will have these posted elsewhere shortly, but in case you missed something. So just a little bit about me. To Ernest's point, I'm involved in the local community in terms of assisting with a few different meetups here in town. Also outside of town, I end up writing for a few places. Folks end up giving me a full-time paycheck over at SolarWinds, so very pleased to be working with the fine folks there. Generally make myself a nuisance wherever I go. So feel free to reach out both in the Slack channel that Ernest and James mentioned or here. I generally don't bite. So I am in Austin. I am in Texas. I'm still kind of working on my my Texas accent. We'll see how well I'm doing here in a minute, I think. But so the topic du jour is container orchestrators. And as you go to define a given topic, you end up, if you're like me, you go and look up the definition. And I had asked myself, what is a container orchestrator? And when I went to go, look it up, I ended up coming away with this analogy of a container orchestrator being fairly similar to an admiral of a fleet of ships, and those, that admiral being responsible for the packing of containers onto those ships, the formation of the ships, the delivery of the goods to their end port. And I think there's a lot of similarities or analogies to draw between what a container orchestrator is responsible for in terms of hosts and getting them together into a cluster, and then scheduling containers onto those hosts and packing them in the right way, making sure that they're healthy. And so I think there's a good analogy to be made there. We are going to talk today about Nomad, Swarm, Kubernetes, Mesos, and Marathon. We're not going to talk about the enterprise distributions or the commercially supported offerings of these things. We're going to talk about the open source offerings that are out there, or the open source projects rather. We won't talk about Fleet, great project being used in production, as I understand, in many different places. The primary organization that was behind that, CoreOS, is I think focusing their forward-looking efforts on Kubernetes while sustaining Fleet for those who are using the project. I do want to differentiate between containers as a service. So we're not talking about Triton or Docker Data Center or ECS, ACS or Carina or others. And so we're kind of bifurcating between those two concepts. The container orchestrators that we'll talk about, you can run them in clouds or on-premise. And the container orchestrator, the CAS offerings are just that, offerings that are hosted elsewhere. So I also want to, say that I'm careful not to use the word comparing here as we go through and look at these different container orchestrators. That's not the intention to ascertain or identify which one is better than the next. I don't know that there's. Well, first of all, we're kind of early in this game, and then second of all, I would say that competition is healthy. Outside of that, just as you've got a toolbox full of tools that are useful for different jobs that you may have, you're going to want different container orchestrators for different jobs, for different tasks. You're going to want a different container orchestrator based on what size engineering staff you have on hand, what their level of skill set is, what your organizational maturity is. There's a lot of factors that go into trying to figure out which one is best for you. So I would say one size doesn't fit all. Moreover, as we go to look through these container orchestrators, it can get, and we're not going to get into this today, but it can get a little bit complex in terms of how each one can be entangled with the next, to the extent that each of these are platforms. For the most part, each of these platforms can run each container orchestrator could run a different container orchestrator on top of it. And it gets very confusing, and we're not going to talk about that today other than just what I just said. So we're going to talk about what each of these container orchestrators do standalone. And to do that, hopefully we can walk through just a category of capabilities and functionalities and do this in a structured way, hopefully. First, we would talk about the genesis of each of these projects and how they came to be, under what premise were they designed, and what problems and use cases were they trying to tackle. Then we talk about who's supporting these container orchestrators, how fast are they moving. Core to any container orchestrator is this notion of host discovery and service discovery. That's going to be both at a host level and at an application level. We'll talk about scheduling and how containers actually instantiated and run on different nodes within a cluster. Very interesting area, scheduling. Then the notion that each of these container orchestrators are platforms, so they're modular and they're extensible. Kind of to the notion of the credo of Docker about being batteries included, but removable. You'll see to varying degrees these container orchestrators have been designed to be modular. Some of them have more opinions built in, and for the most part, you can swap in and swap out opinions. How do you update and maintain container orchestrators? The systems, these control planes themselves. Also, how do they afford for you to update your applications that are running in containers or in jobs? How do they let you do that gracefully? To what extent do container orchestrators monitor the health of the cluster? To what extent do they allow you to monitor the health of your applications that are running in the cluster? Networking and load balancing, you really can't get away from this stuff. To the extent that you are running distributed systems, you're running applications that are written in a microservices-oriented architecture. The network is extremely important, maybe more important than it has been in the past. We'll take a look at how the container orchestrators provide for that. Also, secrets management, to the extent that you've got kind of a classic use case here, to the extent that you've got an application that with a front end that needs to talk to a database on the back end, that application may need credentials or secrets to get at that database. Just as one example of where secrets need to be maintained. And then lastly, high availability and scalability. I think the promise of these container orchestrators is you can, I guess to use CoreOS's motto around Giphy, Google infrastructure for everyone, that the hope here is that container orchestrator can get you to highly scalable deployments and ones that are highly available as well. So for those of us who are coming from an IaaS-oriented background, it's still, we're still talking about a lot of the same things. We're talking about essentially compute, network, and storage. We just use different terms to kind of describe those, and those are on the right-hand side here. Noting the time, I'm going to begin to move pretty quickly. I'll say that, in my opinion, a container orchestrator, it must have the two capabilities highlighted in yellow, cluster management and scheduling, to be a container orchestrator. Otherwise, it's just, if it doesn't have those two capabilities, it probably can't be called a container orchestrator. You'll also see that for the orchestrators that have been around here for a little while, that they've got most of what you see on the left-hand side, not all of them. And then some of them graduate to really focusing on the application, which from my perspective is the king. It's kind of why we have infrastructure in the first place. And I don't think there's any disagreement out there, but we tend to get lost in the infrastructure weeds sometimes. So, to what extent are these container orchestrators providing for applications? Let's take a look at Nomad, first at bat. So the genesis of Nomad here, it was built to both run long-lived services as well as short-lived. And I think you can interpret that as kind of long-lived containers and short-lived jobs or tasks, things that are more batch in nature. So to that extent, Nomad not only supports running and scheduling containers, it also supports running and scheduling jobs, so processes or scripts that you may have written. It is declarative in nature. You go out and define your job in a spec file. It is written in Go. It's designed with a Unix philosophy, and that's the notion that Nomad is there for cluster management and scheduling. And then there are other parts of the HashiCorp offering that get used to bring some of the rest of those capabilities that we just mentioned. So things like Vault and Surf and Console are other HashiCorp technologies that get wrapped around Nomad to bring forward the other functionalities we talked about. Nomad is small in terms of simplicity of deployment, so kind of singular binary type deployments. We'll look at its architecture here in a second, but its support and momentum, most of these projects are pretty young, less than a couple of years old, save for Mesos. That said, Marathon and Mesos is still young as well. Nomad itself started around June 2015, is by and large supported and pushed forward by HashiCorp. Nomad Enterprise is a new offering, is set to be released here soon. Currently, the project is on a .04 release. I think the HashiCorp folks would tell you not to let that confuse you. In fact, this is many organizations are running and using Nomad in production. So don't be confused that it's not a 1.0 release. It is production ready from their perspective. HashiCorp, or the HashiConf, if you kind of measure its momentum in this way, has just picked up steam over time. More attendees coming. The architecture here, really, I think, one of the foundational beliefs and kind of focuses was on it being a multi-region and kind of a tool to federate clusters, irrespective of geography. And so while I've only got one region pictured, you want to envision this happening in multiple regions. Nomad does have to the extent that you do need service discovery, it does have a dependency on console. So to that end, so in terms of host and service discovery and how that works in Nomad, console is there for service discovery. Surf is there for consensus between servers, for just efficiently exchanging information about other servers and other Nomad clients. where they are, how much workload they have. These systems heartbeat between each other every 30 seconds. So conceptually creating and federating clusters is simple with Nomad. All right, in terms of scheduling, Nomad is actually arguably probably has the most advanced scheduler. I think that's maybe up for debate, but I say that because Nomad's one of the few orchestrators that we'll see that does optimistically concurrent scheduling. And so that is to say that multiple servers work on trying to figure out where to schedule a workload at the same time. And so HashiCorp has produced I think it was, 1 million containers scheduled across 5,000 hosts in 5 minutes. So that just sort of speaks to the speed by which scheduling decisions, that scheduling algorithm is run. So pretty, I don't know if how many workloads people out there have that need 1 million containers, but when you do, there's container orchestrators to help you with it. So most of these container orchestrators are modular and extensible. Nomad is probably weaker on this side. It's just a younger project, has intentions to be more pluggable than it is today. Right now, if you wanted to implement a new task driver, which is like a new runtime, you'd need to compile Nomad and get into the thick of the Go code there. All right, so I'm taking a look at the time. We've got a ton of material. I'm going to kind of highlight some of these things quickly. Folks can come back and look at this, but I would say that how you maintain and update the container orchestrator itself is important. You don't want to have downtime as you go to update that control plane. Nomad begins to feed the needs of applications by helping rotate logs if your logs are sent to standard error and standard out. It doesn't have any log forwarding support just yet. It does support rolling updates. So to the extent that you've got an application that's running on these clusters, you need to update your application. You can specify that in your job, and Nomad will help facilitate rolling out the next version of your application. So turning down your old containers and spinning up new ones with your new version of your application. Nomad does keep track of all of the nodes in the cluster, all of the clients, the Nomad clients in the cluster. Like I said, via those heartbeats, using Surf, it does exchange information about the resource allocation on those nodes so that it can make scheduling decisions. It does support monitoring of the applications that are running, that have been scheduled. For long-lived services, Nomad you can tell it to do HTTP, TCP checks, or to run a script on the Nomad client itself and return an exit code to determine whether or not your application is healthy. So these are important capabilities kind of to distinguish between how the container orchestrator provides for its hosts and their health, as well as your application's health. Nomad's young in its walk towards networking and load balancing. To the extent that you're using Console, it does provide DNS-based load balancing through Console. Nomad's the only container orchestrator today that still only supports kind of shared IP addresses with the host. And so Nomad will dynamically allocate an internal, a port number in the range that you see each time that a job is scheduled and needs to communicate with the network externally. You'll see that most of the other container orchestrators have moved on to an IP address per container. One advanced area for Nomad is secrets management. So Nomad has a great integration with HashiCorp Vault for storing secrets and providing secrets to jobs as they spin up. Nomad, we talked about the speed by which Nomad schedules jobs. We also made note of the million containers across 5,000 hosts in 5 minutes test that was done. The measuring measuring scale and performance and doing so in in an even-handed fashion across the container orchestrators is a little bit of a challenge, not one that I've seen folks take on just yet. I've seen each project take on its own scale and trying to measure that in one environment using a certain type of container, and then different projects use different containers and different infrastructure to try to measure their scale as well. And so it's a little bit it's not an apples to apples comparison across them just yet. Some pros here: that Nomad's easy to pick up and use. Some cons are that it's less extensible and pluggable today, younger on its approach to networking, moving quickly, and so are all of these projects. Swarm is moving quickly, and again, kind of noting the time, what I'll say is that we're going to talk about Swarm 112 today, which is Swarm mode or Swarm Kit. You're going to see some notes in here about Swarm standalone, which was what you would have had with with Docker 111 and prior. Going forward, there's a push to go to Swarm mode, so it's 112 and after. That said, Swarm was created to be easy to use. It was originally an imperative system, now declarative through the use of specification, Docker files and compose files again. Swarm's architecture isn't as complex as what you'll see in Kubernetes and Mesos, and is kind of a natural conclusion, perhaps a little bit easier to pick up and use. Also a natural conclusion there is probably not quite as powerful as those other two container orchestrators as of yet. Again, this one's written in Go. It is lightweight, it is modular, and it is extensible. So quick difference between Swarm 111 and 112, the gist of which is much of the capability that was external prior in 111 is now built into the Docker daemon itself in 112. And 112 begins to take some cues from other container orchestration projects. So it begins to use Raft. It begins to bring forward this notion of a service, a Docker service, which is how applications are really represented within Swarm. Swarm also takes advantage of some Linux kernel capabilities that have been there a long time, IPVS, in order to provide some mesh networking. We'll talk about that. It's pretty interesting. So lots of support for this project. There are a small set of core maintainers on the project, lots of commits happening, tons of Docker meetups happening around the world. Docker is very purposeful about those meetups. As a matter of fact, this week is Docker's Global Mentor Week. At its, being offered at all of its meetups around the world. Swarm Kit, it's important to note the Swarm Kit that in these slides is highlighted in yellow to kind of differentiate Swarm Kit, 112 and going forward. It's important to note that the Swarm Kit code base is new and separate from what Swarm standalone code base was. And so the Swarm Kit's code base itself is just about 4 months old. So again, a young project in this respect. I think a lot of lessons were learned from 111 and built into 112. So very much so headed down a great path. So to the extent that I said that this new Swarm Kit, this Swarm mode has leveraged either constructs or capabilities from other container orchestrators, in a smart way. One of those is by leveraging HashiCorp's GoMemDB for storing cluster state, for doing some in-memory kind of storage of the key value pairs that it exchanges through Raft. It also uses Surf to HashiCorp Surf to efficiently exchange consensus information between managers. So service discovery is also provided for. Used to be that in Docker 110 there was embedded DNS, and you'd use DNS for that service discovery, or you'd tack on a standalone key value store like etcd or console. With 112, services are now, and service discovery itself is now built into Docker daemon itself, making it very convenient and easy to deploy and get started with. So we talked about scheduling with Nomad. Scheduling in Swarm works is not optimistically concurrent, but does have some strategies and filters by which you as a user are empowered to define the methodology by which you'd like for that scheduling to happen, how it is that you'd like for containers to be scheduled onto nodes, whether you want to bin pack all of your containers onto a given node and kind of fill it up before moving on to the next node, or if you just like to spread around the distribution of those containers evenly across the nodes in the cluster. So Swarm mode itself took maybe a step back here and only supports the spread strategy at the moment, but we'll be stepping into other strategies that it previously supported in 1.11. Also step back a little bit in terms of modularity. It used to be Swarm standalone had a pluggable scheduler, pluggable key value store. Now, with 1.12, you get the convenience of having those built in, which is great to the extent that that those opinions and those capabilities are what you want. Swarm 1.12 added the ability to put hosts into maintenance mode and drain existing workloads off of a node in order to maybe do physical maintenance to the actual server that's running these workloads. So that's certainly a step forward. Also now has support for rolling updates. So to the extent that you're updating your application, you can use different strategies to roll out updates to your application. Again, noting the time, going to push forward, call out a couple of things. IPVS, highly efficient load balancing, and that happens inside of the Linux kernel. Some great things. Docker Swarm doesn't have secrets support just yet, but is tracking towards that in 1.3 release. Again, we probably won't touch the high availability here. It's kind of a sticky subject. There are some tests that have been run and available out there. Swarm is, like I said, kind of a recap, very easy to use, especially with 1.12. Get up and going quickly. Lots of capabilities being built in. That team is moving fast and eliminating gaps very rapidly. Swarm itself focuses on container scheduling, and so doesn't deal with non-containerized processes just yet. But Swarm Kit has been revised such that you may in the future see it being able to schedule non-containerized processes, maybe VMs even, maybe unikernels. So Kubernetes just has a ton of steam behind it. Is written in Go again. You're kind of seeing a theme there. Was originally created by Google, donated to the CNCF, Red Hat, CoreOS, and many others have come to bear on it. It's probably the second most popular project on GitHub outside of TensorFlow. It is opinionated, and because it's opinionated, it has a lot of functionality built in. It's a declarative model as well. A little more complexity that you're seeing here in this diagram, which is good in that you get more out of the box, so to speak. But is just more constructs and things to learn, more things to deploy. So something to keep in mind. Extremely fast-moving project, like I said here. Again, purposeful about community, engages community a little bit differently than the Docker project does. Each of these projects engage community a bit differently, depending upon how they're governed and how they accept pull requests and that kind of a thing. So let's move forward to get to the juicy bits before our time runs out here. Scheduling is provided by KubeScheduler, which is the built-in scheduler. It is swappable to the extent that you want to pull in a different scheduler. It also uses similar things like strategies and filters, just like Swarm did. In this case, they're called predicates and priorities. They help identify what node to schedule a container on, and when to the extent that multiple nodes are identified, it uses priorities to figure out which of those nodes, in fact, are the best fit based on requirements that you specify. Highly extensible, arguably probably the most the container orchestrator that's built like a platform and intended to be built upon. Potentially, really great thing. Also could potentially suffer some of the same issues that OpenStack has suffered in terms of just how many people have come to bear on it and have brought to the project. So yeah, other interesting things. Lots built out of the box by way of health monitoring, by way of monitoring providing metrics for the applications that are running. Again, only does container scheduling. So it doesn't do, well, actually, I'm sorry, it does do job scheduling. It does do scheduled tasks outside of containers. Great, okay, so let's, does do secrets management. Let's skip on into Mesos and Marathon. Some interesting things to call out with this project. One is that don't get confused between the two. There are, in fact, two separate projects, Mesos and Marathon. Mesos has been around, predates Docker, has been around, was kind of built of the days of grid computing and distributed systems, written in C++ and Java. Marathon, a younger project, a little over a year old, by and large supported and pushed forward by Mesosphere. Powerful system Mesos is in that it's got two levels of scheduling. One happens at the Mesos level, which handles the cluster themselves and their resources. And the second is at a framework level where Marathon and other frameworks sit. Mesos, the master itself, offers up makes resource offerings into the frameworks, which then take those offerings and execute jobs on the systems. So we're almost hitting our feet of making it through 4 container orchestrators in 30 minutes. We're hitting our time. What I'm going to do is jump towards kind of the end here and say that this is a generality, but is by and large accurate, and has been reviewed with maintainers of all of these projects. And I think is a fair synopsis. Lots of overlap in capabilities between these orchestrators. But if you look at the left-hand side in terms of what's easier to use, what has less, fewer capabilities, what's maybe has higher scale, is more mature, has more modularity. This is generally true. These projects are moving very fast, though, and actually makes presentations like these hard because it changes pretty fast. With that, again, I'll post the link for the slides will be out. You can go back and review what you missed. I'll be sitting in Slack to take questions and generally, chat, talk shop.
All right. Hey, thanks, Lee. That was a great presentation. Yeah, like Lee said, he's going to be hanging out in the chat in Slack. Hit him up with questions. We'll be back for the keynote starting in about an hour and 20 minutes, and we'll see you all then.